Okay, so here's the deal. When we are solving a system, some of you have come across issues with the graphing. Part of it is you're not being accurate with your graphing. You're not using rulers. You're not using even intervals. You're not using the lines of the graph paper. All of that is going to lead you to not get an accurate graph. And then when you're looking for where two graphs on the same axes cross, each time you're a little inaccurate, then it's not going to cross at numbers. And sometimes when we graph, it doesn't cross at integers. So we're supposed to guess what fraction we're looking at, and that's nearly impossible to do. So this is not the common way of solving a system, is through graphing. Unless you have access to a graphing calculator or a program like Desmos where it can do the graphing for you, and all you have to do is bing, put your finger on the dot of intersection, and then it tell you what the coordinates are. But that's not you really figuring out how to do things. So we've come up with other ways to solve a system. So one of the ways that we're going to talk about to solve a system through algebra is a strategy called substitution. So that's what our objective today is to learn to solve a system of linear equations. Those are the only kinds of systems we're dealing with right now. Algebraically, so that means math only, algebraically, using substitution method. Okay. Using the substitution method. So, we've talked about substitution in the past. What do you guys remember about the word substitution? What does that mean, to substitute? Okay. To replace. And what are we normally replacing when we do substitution? Justin?
Variables for their values.
Okay. So normally what we'll do is have some sort of equation with a bunch of variables, and then someplace they'll tell us what the variables equal. And then we'll substitute in those values for the variables, and then we're actually able to solve it. So we replace a variable with its value to solve a problem. So that's precisely what we're going to do, but what we're going to be substituting in may not be what you're used to seeing a value, because when we were doing this, it was like 2x plus y equals 5, and x equals 1, and y equals -3. So you would plug those numbers in, and then you would see if it was true, or if you wanted to figure out what y was and they only told you the x value. Well, on this one, chances are the values you're going to see are going to be what we call a monomial, and a monomial can be a number alone, it could be a variable alone, it could be a product of numbers and variables. So let's write down that word as well, so when you hear me use it, you know what I'm talking about. So it's a number, a variable, or a product of numbers and variables. Okay, so for example, 2 is a monomial, x is a monomial, 13y squared z to the 5th is a monomial. Okay, and I think we talked about this when we were doing exponent rules. We talked about monomials. So what we're going to do now is we're going to switch gears, and we're going to use this algebraic method substitution to help us solve a system. Okay? Okay. So here we go. I'm going to give you two equations, and the directions are going to say this. Solve the system of equations algebraically. Now, what's cool about this strategy is that you can use it all the time in a system. There's some problems that lend themselves to it, and then there's some problems you have to do some work to be able to use it. But you can use it at any time. I'm going to teach you some other strategies next week, but this one can be used all the time. Sometimes, though, when you use it with some equations, you create a bunch of fractions, and that becomes a nightmare to deal with. So there's other strategies that help alleviate that. So here's what we look for. We've got two equations, both with the same variables. That's what makes a system a system. And what you're looking for is there one variable that all by itself and it doesn't have anything attached to it? So there's nothing being added or subtracted from it. There's nothing being multiplied or divided by it. So that's what I'm going to write over here in colors. Look for one variable that is alone on one side of the equation. Look for one variable that is alone on one side of the equation. So in these equations, you see a variable that meets that condition, that it's alone on one side of the equation. Yeah, in fact, in both of them, this y is alone and this y is alone. Okay, that doesn't always happen, but in this particular system, that's how it's written. So here's what we're going to do. Let's look for one of them and tell me what y equals in that equation. So what does y equal? I want to know what it equals just for one of the equations, not for both of them. That would be too confusing. Kyler? 10. Okay, not in this. There's nothing with 10. It says y equals x minus 3 and y equals 2x. So what does y equal in one of the equations? Taylor?
4.
Exactly. You're playing with your watch. What does y equal? Pick one of the equations and tell me what y equals.
2 to 3.
No, there's nothing there that says y equals 2. No, doesn't. We don't have any equation that says y equals negative 3. You got to read what it tells you, but it's right there. Joe? Y equals 2x. So what I'm going to do is take this value that y equals 2x, and I'm going to substitute it into the other equation to take the place of y. So I'm going to write over here, substitute the expression that equals y in one equation. Substitute the expression that equals y in one equation into, or in place of, in place of y in the other equation. So we're going to say y equals 2x. We're going to take that 2x and we're going to substitute it into y into the other equation. So now I have 2x equals x minus 3. All right? What do you think I'm going to do at this point? Jonathan? I'm going to subtract 2x from both sides? Then that's going to take everything away from one side. What is it in general that I'm going to do at this point? What can I do mathematically? Jonah? No? And why would you want to do that? Okay, so we get variables to the left, And what's 2x take away x? X. So basically what you just did in that step is you solved for one coordinate of your solution. You solved for the remaining variable. So what I just figured out was x equals -3. So when I write my solution to this system, where do they intersect? I know the x coordinate. How am I going to figure out the y coordinate, though? Oh, somebody else has to be able to give me an answer here. Aaron? So which equation do you want to use? Okay, so he's saying, let's take that value for x, and let's substitute a second time back into one of the equations, and let's figure out what y is. So we get y equals 2 times -3, which gives me y equals -6. So I'm going to write here, substitute the answer into an original equation and solve. So we can't solve an equation when there's two variables present, but if I can get from two variables to one variable, then I can solve it. So what I just figured out, this point is going to tell me the solution to the system. This point is where the lines intersect. Okay. Now I knew I was going to get a point because upon inspection I could have very quickly noticed they don't have the same y-intercept and they don't have the same slope. Therefore, I'm going to have to get a point here. Okay? So substitution is just merely replacing a value with something that it equals. And the way we do it is to eliminate one variable so I can solve. All right, let's try another one. You guys good? Yep. All right, let's do another one like that, and then I'm going to give you harder equations. So, same idea. Here's your two equations. Y equals x plus 4. Y equals 2. Our goal is to create one equation that has only y's in it or only x's in it. So, what I have dictates what direction I get to go. So what am I going to substitute in for what, according to what I have here? 2 is going to go in for y, okay? So we're going to take this value and we're going to substitute it in for the variable y in the other equation. So we have 2 equals x plus 4. And now my job is to figure out what x is. So I'm going to use the symmetric property and rewrite the equation as x plus 4 equals 2. And then what do I do to get x alone? Subtract 4 from each side. So remember how we did a unit on equations and solving them? Now it's coming back. Okay, Cameron, you got to write down this example. But that's half of my solution. Okay, how can I figure out the y value? Sylvia?
So you do y equals 2 times -2.
Where's 2 times -2?
You have to do it for the other equation.
Okay. Well, the other equation says y equals x plus 4. I'm not sure where -2 times 2 comes from.
Don't you have to multiply it, like for the one that says y equals 2?
Doesn't that tell you what y equals? There's nothing there that says 2x. That would be when I would multiply if there was something happening to it. So this problem is kind of interesting that we actually don't even have to calculate the y value because they told it to us. There's your solution. That's the point, if you graph this, where your two lines would cross. Okay? Let's get to a harder one. What if we have something that looks like this? Y equals 3x plus 8 and 8x plus 4y equals 12. Do we have an equation that has a variable all alone? Yeah. What does that one say? Okay. Y all by itself. And what does it tell me has the same value as y? 3x plus 8. So here's what I do. I'm going to substitute in 3x plus 8 in for y. Now I have to be careful because there's other stuff going on in that equation and I have to follow what it says. So I'm not touching the 8x, I'm not touching the plus, and I can't even do anything about the 4. The only thing I can do is substitute in for the y 3x plus 8. That equals 12. So we did equations like this back when we were studying our equations, so that we just have some work to do. 8x is 8x. What am I going to do now? I'm going to have to distribute. What's 4 times 3x? 12x. What's 4 times 8? 30. There's no x, just 32. Okay, now what? Yeah, we have some like terms here, so let's add them up. And what's 8x plus 12x? 20x plus 32 equals 12. Now what? I'm going to get the constants together, doing opposite operations. I'm going to put up here so I can do the math a little better. I'm going to subtract 32 from both sides. So always put my bigger number on top when it's a subtraction problem. And I get 20x equals negative, bigger number's negative 20. Oh, now what?
Divide 20x.
I need to get rid of the 20, not the x. I'm going to divide both sides by that coefficient, 20. And I get x equals, what's negative 20 divided by 20? Negative 1. So I've got half of my answer. I have the x coordinate. How do I figure out the y coordinate? What do you think would be the best thing to do? Cameron?
Oh, no, just touching.
Nope. You got to do it on your homework, so you might as well come up with a thought now.
Oh.
How am I going to figure out the y coordinate? How is this going to help me figure out the y coordinate? How's that x equals negative 1 going to help me?
Put the negative 1 where the y is, and y equals 3x plus 8.
No, it says x equals negative 1. I can't replace y with an x value.
Replace 3x with negative 1x.
Okay, I'm not going to replace 3x with negative 1x. I'm going to replace only the x.
Yeah, that means that.
Only the x. So now I have y equals 3 times the x value, which is negative 1 plus 8. So 3 times negative 1 is?
Negative 3.
Negative 3. And what's negative 3 plus 8? 5. So what that tells me is the answer to the y coordinate. So now I've got the ordered pair is negative 1, 5. So again, let me just show you how you can verify you've done this correctly. What you're going to do is take these coordinates, negative 1 and 5, and substitute them into each equation and see what you get. So if we substitute in 5 for y and negative 1 for x, do we get something that's true? Well, we get 5 equals negative 3 plus 8. We get 5 equals 5. Is that true?
Yes.
So it's a solution for that one. So let's try the other one. So we're going to have 8 times the x value, negative 1, plus 4 times the y value, 5. Does that equal 12? So we have negative 8 plus 20 equals 12. What's negative 8 plus 20?
12.
So I get 12 equals 12, which is true. So what that says is it verifies, yep, you found the right answer. Okay. Hi. You guys want to try here? I'm going to give you one more. I'm going to have you guys try this one on your own. This is number 4. Y equals 2x plus 1, 3x plus 4y equals 26. See if you can come up with the correct ordered pair. All right, so again, we have a variable by itself. It's y. We're going to substitute it in for the y in the other equation. That gives me 3x plus 4 times the quantity, 2x plus 1, equals 26. Solving out, we get 3x. Distributing, we get plus 8x plus 4 equals 26. We have like terms. We combine them, adding them. We subtract 4 from both sides. We get 11x equals 22. We divide by 11. We get x equals 2. Notice how math is now becoming more complicated because there's more to do. Substitute it into this equation. We get y equals 2 times the x value of 2 plus 1. Because that's what I want to do, is figure out what's the y value when x equals 2. We get y equals 5. And that becomes the second part. So the homework tonight is going to be from the green textbook on page 365, 1 through 10. All right, good luck with that.